ఎంతమంది జాయిన్ అయ్యారు? Good morning, everybody. I welcome all the online and offline participants for the 5-day faculty development program on outcome-based education, teaching, learning, and evaluation. So our session is about to start, and I request everyone to join the session immediately. I welcome Dorsam sir for this session. Sir, good morning. Sir, can you hear our voice?
Yeah. Am I audible?
Sir, yes, sir. Very clear. Sir, they will make you co-host and you can share your PowerPoint, sir, while presenting.
Yeah. Shall I start?
We'll wait for another 4 to 5 minutes, sir. Online participants are yet to join, sir. Only few have them joined. They'll join, sir.
Okay.
Thank you, sir.
Thank you. Shall I wait for some time?
Yes, sir. Please, sir.
Okay.
Good morning. Once again, I welcome all of you for this a 5-day faculty development program on outcome-based education, teaching, learning, and evaluation. This is the 4th day of this faculty development program. Today we have with us the resource person, Dr. Doraswamy, Professor of Department of Education, Regional Institute of Education, NCERT, Mysore. Here, he is with us to share his resources on the topic strategies for development of higher order thinking skills in outcome-based education. I welcome you, sir, for this session. Sir, can you hear a voice, sir? Sir, kindly unmute yourself, sir.
Okay.
Yeah. Is it clear, sir?
Yeah.
Yeah, shall we start the session, sir?
Yes.
Okay. I welcome Shri B. Ramesh Chandra Babu Garu, Department of Mathematics, to come on to the dais to chair this session. Welcome you, sir. And I also welcome Shri T. Raghuraman Garu, Department of Physics, to come on to the dais to act as reporter. Welcome you, sir. And I request chairperson to continue the proceedings. Thank you.
Good morning to one and all. Myself, B. Ramesh Chandra Babu, lecturer in mathematics. I feel very proud to introduce today's chief guest, Dr. K. Doraswamy Naidu Garu, who rendered immense service in the Department of Mathematics, in the Department of Education. Yes, he also belongs to the mathematics department. Coming to his education, he completed his post-graduation in mathematics at SV University and also post-graduation in education in SV University. He did his PhD in Mysore University. Coming to his professional experience, at first he joined as a lecturer in Regional College of Education, Mysore, NCERT, and he worked as a reader in Regional Institute of Education, Mysore. After that, he worked as a professor and dean of instructions, Regional Institute of Education, Bhubaneswar, and then he worked as a principal, Regional Institute of Education, Bhubaneswar, NCERT. He worked as a professor and head in the Department of Education, Survey and Data Processing, NIE, NCERT, New Delhi. And also he worked as a professor and head and dean in the Department of Teacher Education and Extension, NIE, NCERT, New Delhi. After that, he worked as a principal, Regional Institute of Education, Mysore. Coming to his research, he worked as a research scholar in the field of psychometrics in the Department of Mathematics, Indian Institute of Technology, Kharagpur, and he did his doctoral study on development of competency-based curriculum design for methodology of teaching mathematics and its validation. He has completed 9 research projects. The national evaluation study on program of mass orientation of school teachers and its impact in Kerala state. This program was sponsored by MHRD, Government of India. He worked as a project leader for this project. And then he worked as a project leader for the project analysis of question paper of secondary and senior secondary board of examination of southern states. This program project also sponsored by MHRD, Government of India. He worked as a team member in the project, a study of impact of improvement of science education in schools. And also in the project, he worked as a team member. The project is study on innovations in primary mathematics education and teacher education. Coming to his research, under his guidance, four PhDs were awarded. And then coming to his publications, he has published papers, articles on different aspects of school education and teacher education in journals such as Indian Educational Review, Journal of Higher Education, Journal of Indian Education, DPEP calling, UGC newsletter, studies in educational theory and practices, experiments in education. The training and extension activities of Mr. Naidu Garu is, he participated in education policy planning and analysis, Harvard University, USA, and then he, as a senior faculty member of NCRT, he has participated in policy analysis and planning, formulation of projects, preparation of training design, organization of training programs, workshops, seminars, and consultations, development of curriculum and instructional material at state, regional, and national levels. Designed and conducted professional programs on constructivist approach to teach, learn, and assessment in mathematics for teachers and teacher educators. Academic association with universities, national institutes, and organizations, or he served as a educator of MPhil and PhD thesis in education of a number of universities. He served as a member, chairperson, advisory committees, statutory bodies, committees of MHRD, NCTE, NCERT, IGNO, NAC, NIOS, MANUU, Hyderabad, IITE, Gujarat, Central University of Rajasthan, Central University of Tamil Nadu, NERC, KVS, NVS, and SERTs. Currently, he is working as a member of Standing Committee of NCTE on evaluation of innovative teacher education programs, member of Board of Studies in Education, Maulana Azad National Urdu University, Hyderabad. Thank you, sir. We are very fortunate to have such a great personality as a chief guest. He is going to deliver his lecture on strategy for development of higher order thinking skills in out-based education. Thank you. Thank you, sir.
Thank you, Chairman of the session. Good morning to everyone and welcome to my presentation on strategies of teaching for development of, just a minute, I will. Yeah. It's, Is it visible? Are you able to see my PPT?
Yes, sir.
Okay, thank you. Thank to the chairperson of the session for a long introduction, which I don't require since I'm a superannuated faculty of the NCERT. I given the topic strategies for developing thinking skills. And the last 4 days, a number of topics were discussed on related to outcome-based education. They're all pertinent to understand the what, the why, and the how of objective outcome-based education. The outcome-based education is not a new concept or a system of education. It has been there for the last almost 4 decades, maybe in the name of competency-based education. And now many countries use what is called the standard-based education, which is almost similar to the in philosophy and
Sir, sorry to disturb you, sir.
Yeah.
Sir, can you keep the PowerPoint in presentation mode, please? So that it will be visible properly, sir. Or shift, press shift F5, sir.
Is it okay?
No, sir. You press shift F5, sir.
Madam,
Shift.
సార్ గుడ్ మార్నింగ్ సార్, నేను విశ్వనాథ్ మాట్లాడేది.
చెప్ప
ఏం లేదు సార్, అది యాక్చువల్ గా అక్కడ ప్రజెంటేషన్ ఎంటైర్ స్క్రీన్ అని చెప్పేసి మీరు ప్రజెంట్ చేయండి. లేదంటే ప్రజెంటింగ్ ఓన్లీ షేరింగ్ ది విండో అంటే కంప్లీట్ రాదు. అది
I'm visible to them.
Yeah, you are visible. Your presentation is also visible. Probably they wanted to project with the bigger screen, sir. That may be the reason.
Okay, what should I do? Fit window? Fit to window?
With window, sir.
Is it okay?
No, sir, not it. Sir, at the bottom of the PowerPoint, you just see, sir, there is a grid and a presentation mode. You can press that also, sir. Next to that, sir.
Okay.
Next to that.
Yeah, this.
Next to that, sir. Yes.
Okay.
Yes, sir.
Oh, sorry. Yeah, I was telling you about the different models of outcome-based education as competency-based education and the standard-based education. Now, these systems of education were introduced in different subject areas at different levels of education, including engineering, medicine, business education, etc. Now, what is important is that, as the title suggests, that the outcomes that are identified are to be aligned with the content, the learning activities, and the assessment for it to be successful. And also there is a need to create an learning environment based on constructivist philosophy, a deep learning, and outcome based, replacing the instructivist pedagogy, philosophy, surface learning, and content based curriculum designs. Now my starting point is a reference to what is called the information processing theory. Now we all know that we are bombarded with lots of information day in and day out through various sources, print media, TV, and so on. all that we as a human beings do is we don't receive all of them and store. And even as a learner, when he's presented with information, he or she doesn't store that information in his or her computer, the mind. But then as a human being, we are all capable of the processing of the information. Now, when you process, we make use of different thinking skills, resulting in some product, which is called the knowledge or the content. So I would like to bring to you a few items that I have found in Times of India today, which gives you a lot of information, but I would like to characterize them later. The Bangalore's 2K cases, I hope you can remember a few of them. I didn't make a slide for this. The Bangalore's 2K cases, a 5-month record, says the CM. Then 72,000 students go abroad this year after 55% dip in 2020. There is another item that must interest us, which is related to the topic also. Harappan people ate multi-grain, high-protein laddus, says a study. This was a 4,000-year-old food balls found in Rajasthan. The archaeologists found that this as balls of mud, but then they realized that found that they are of a different color, and therefore, as archaeologists, as scientists, they have taken that as a problem to identify what that ball is about or what it contains. And the chemical analysis of these balls reveal that they are the multi-grain, high-protein, the laddus. Now we also see, which interests me also, every day I see a newspaper first to the sports page. There are items related to India completing the series hat-trick, pulling off win in all 3 formats against England. There's another item which should make people happy. That is India sign off with a record medal tally in shooting. And I believe that the large contingent will be from shooting in the Tokyo Olympics 2021. And there is a impression that the shooting team will win a few medals for India in the Olympics. There's another a concern which is not reported in this paper, but then as a follower of badminton, now I feel that the badminton players, particularly Sindhu, Saina, Srikanth, and a few others, they are not performing up to the level they can in most of the international tournaments. There's also a news item. It's about Amit Shah predicting 26 out of 30 seats that went for polls yesterday. So what we find is they are not there for us. Many of them may be a piece of information, for us, and some may be factual information, but then those who have produced is not reported just the factual information. They are the statements based on the information. So there is a process that has gone in analyzing the data and then bringing out some of the information for us. It is an information for us, but then these information are the processed information. So here the editors, political analysts, the writers, the historians, they have now described some of the events. Some information is a summarization of the information. Some are predictions, some are opinions, some are critical analysis, and there are a few graphical representations which probably I can now interpret, and many of you can now interpret, which are not interpreted in the newspaper. And then some, we can go beyond the information that is presented in the graphical form. So the information that we receive or a learner receives is processed. Process used based on the thinking skills. Okay? And then this would result in the content. The different process skills are used leading to process the information, leading to different kinds of knowledge. So these two outcomes are interrelated. Content cannot be separated from the development of thinking skills. Now, even the learning outcomes are classified into the product outcomes, which are in some authors refer as academic outcomes or subject outcomes. And the developmental skills, they are developmental because there is no end to acquiring the mastery or the skill of those processes that are used. So we have two kinds of outcomes of processing the information. One is the content, the other is the developmental outcomes. Like the learning outcomes are classified into product and the process outcomes. And the process outcomes are the developmental in nature, and we can find a lot of difference in the developmental skills of the learners. Whereas almost all learners can attain the product outcomes or content-based the outcomes. What is it? I'm not able to. Krishnadappa is gone, I think.
Sir,
Yeah. Should I minimize, or I'm not able to move the slides?
sir, left to lower corner lo unnadi chudandi sir, next button.
లేదే ఉంది కానీ ప్రెస్
It is not working. Okay. అదే మీరు ఇందాక మౌస్ తెచ్చారు చూడండి సార్ అక్కడ.
అదే ఇక్కడే నాట్ మూవింగ్.
మినిమైజ్ చేయండి సార్ ఇంకా. escape button press చేయండి సార్.
Right. Struck.
Sir, please minimize the presentation and try again, sir.
No, that. Okay, let's. I think I'm not visible. No? Not only able to. I'm so sorry.
Sir, please share your presentation, sir, again.
Eh? I'm not able to minimize.
హలో సార్, వాళ్ళకి స్క్రీన్ షేర్ చేయండి సార్. వాళ్ళకు స్క్రీన్ ప్రజెంటేషన్ వాళ్ళకు
Screen.
వాళ్ళ స్క్రీన్, మీ స్క్రీన్ వాళ్ళకి షేర్ చేస్తే గినా వాళ్ళే ప్రజెంట్ చేస్తారు. డెస్క్టాప్ మీరు ఏది ల్యాప్టాప్ వాడుతున్నారు సార్?
అవును.
Sir, mail us the presentation, sir, to my mail ID. I will present from here.
Okay. No, I'm not able to close this.
You press escape button, sir.
Okay. Shall I share again? Right?
Yes, sir, please.
సార్ ఏదో హ్యాంగ్ అయినట్టు సార్, ఒకసారి లాగౌట్ అయ్యి మళ్ళీ లాగిన్ అయితే బెటర్ అనుకుంటాం.
Okay. Oh, hang on. Okay. Let's review some of the concepts that are included in the title. And this is thinking skills and teaching thinking skills. Thinking skills are the mental process which are goal-oriented and that include remembering, formation of concepts, planning what to do, reasoning, problem solving. And skills commonly mean expertness, the facility to do things. And this term also refers to what one should know and be able to do to succeed in a task. Thinking skills means combining thinking and skills. Thinking skills means expertness, practical ability or facility in the processes of thinking. And teaching for thinking skills includes the pedagogical approaches through which various strategies and procedures, which include say algorithms that are used to process the information and develop other thinking skills. Now, thinking skills, as I said, are the developmental outcomes, and these thinking skills are broadly classified into inductive thinking skills, which include comparing, identifying patterns, and generalizing. The observations are processed using these derived skills like comparing, defining patterns and generalizing, and the observations and also the informations which may be the processed products. That means with a generalization, sometimes a concept will become a piece of information for further processing of the information. And there are skills like explaining, predicting, and hypothesizing. These are included under the deductive skills. These plus the ability to assess the validity of the conclusions that are drawn, the generalization that are drawn, the concepts that are conceptualized, and also identifying irrelevant information or some of the misconceptions, overgeneralizations, undergeneralizations. These are possible outcomes of processing the information. And the person who is critical in his thinking can identify the misconceptions, the overgeneralizations, the undergeneralizations, or partially true conclusions or invalid, say the conclusions. These together they constitute the critical thinking. Critical thinking includes, as seen in the earlier slide, that it includes critical thinking includes, which is also a derived skill from the inductive thinking and the deductive thinking, and this critical thinking includes the inductive thinking skills such as the ability to generalize, compare, recognize patterns, similarities, etc. And the deductive thinking skills that includes the ability to explain, predict, and hypothesis, and ability to validate existing statements or the generalizations or statements as conclusions, statements as generalizations, statements as concepts, and then identifying the validity of those statements. No, the hearts, there are different categorization of higher order thinking skills, and different people have given different classification of the higher order things. But higher order thinking skills includes the critical and the creative thinking, and the problem solving. Some categorize logical thinking, reflective thinking, metacognition, and creative thinking as higher order thinking skills. Some include problem solving also as a component of the higher order thinking skills. As per the Bloom's revised taxonomy, the higher order thinking skills refer to analyzing, evaluating, and creating. And some include only critical and the creative thinking abilities as the higher order thinking skills. And the higher order thinking skills from different dimensions include the critical and creative in terms of thinking dimension. In terms of the cognitive levels, as per the Bloom's taxonomy, includes analyzing, evaluating, and creating. Now, it can be related with the thinking dimension. The analyzing and evaluating refers to the critical thinking, and creating, which is what was called the synthesis in the original Bloom's taxonomy, the creative thinking. The contents that are amenable for developing the higher order thinking are conceptual knowledge, and some include metacognition also as a knowledge that helps developing the critical and the creative thinking. Let us look at the kinds of the content knowledge or the subject matter knowledge. It includes factual knowledge, and mind you that factual knowledge is not included for or considered as a knowledge amenable for developing the higher order thinking skills. And the factual knowledge includes information about terminologies, labels, symbols, notations, and symbols. Now, but then factual knowledge is also defined as a form of content which is a singular occurrence, which has happened in the past, may exist in the present, but has no predictive value. So in mathematics, we define fact as a statement about a single concept. It is one and only one mathematical object that is unique in a mathematics system, and such a unique mathematical object is called a fact. Now, these facts refer to individuals, events, and objects. Objects mean different things for different subject experts. For mathematician, the objects are the numbers and the symbols, geometrical figures. For a biologist, it is the plants and the animals. For a historian, the events that have happened in the past. For a physical physicist, see, it may be the motion of certain objects. For chemists, it may be the organic and the inorganic elements, metals, compounds, and and then knowing about their properties. Now, some examples of factual knowledge is radius of Earth at the equator is 63,84,160 the meters. Okay, this is a factual information. And for a mathematician, this a natural number 1 is the unit of the decimal number system. A couple of days back, I read in Hindu, to be precise, it was on the last Friday, and it was reported that tulip garden in Kashmir is the largest. There cannot be another, if it is the largest, there cannot be another largest garden in India. Therefore, in that sense, it becomes a unique observation. So, unique observations that are unique or singular in occurrence, which have no parallel observation, are called facts. The conceptual knowledge can again be classified into concepts and generalizations, and principles, laws, generalizations, axioms that are also included under a broad category of generalizations. And there is some variation in terms of their the observations that are considered in forming such kinds of generalizations, and also the applicability of the generalization. Accordingly, these generalizations can be arranged on a continuum from simple generalizations to laws, principles, and theories. And the concepts are a kind of a knowledge that are related to a class of objects. And class of objects are given a name, what we call as a concept name, which is only a term. If a term is taught, and usually in the nursery and the primary schools, concepts are taught by giving the name of the concept. So it is, names are memorized. It is therefore this category of knowledge have not included definitions, whereas some people include definitions. I consider that the concept name and the definitions are some of the aspects of a concept that go into the teaching and the learning of the concepts. We'll discuss about those aspects and how concepts are learned so as to design a strategy for teaching of those concepts. And generalizations, as I said, are inferential. I have not said, but generalizations are a kind of knowledge content that are inferential in nature, underlying inferential in nature. They are not just observations, they are the extensions of the observations, and there are different process skills that are used or thinking skills that are used in arriving at such generalizations. So there are inferential statements that relate to or more concepts. There are relations between concepts, I will explain to you later, and which also helps you to deciding on the kind of strategy that you may have to plan and then implement if you are teaching for developing the thinking skills. So they are generalizations are inferential statements that relate, connect two or more concept, not in terms of inclusion, exclusion, not in terms of superordinate or subordinate or coordinate concept, but in terms of the relations. And unfortunately, some of these relations or properties, which are generalizations, are also included in teaching of concepts. Unfortunately, it is because of lack of understanding the nature of the different kinds of the knowledge. The third category includes the procedural knowledge. This is also considered as academic rule, which relate to formulae in different subjects. And the procedural knowledge tells how to do. Therefore, the algorithms and the steps that we use in construction of geometry, the guidelines that we follow in conducting experiments in physics or chemistry or in other science subjects or engineering subjects fall under the category of the procedural knowledge. What is important to note is that these procedural knowledge has a basis in the conceptual knowledge, that is concepts and the generalizations. So some examples of concepts are parasites are organisms that feed on other organisms. Transplantation is the process by which the seedlings from a plot are planted in the field. I've taken from different subject areas. Now, in mathematics, I might have given you a large number of examples of facts. Not many number examples of facts. They are not many, but then the mathematical knowledge or the scientific knowledge or knowledge in social science consists of many concepts. I've taken to give a representation to different fields of knowledge some examples of concepts. Like mass of an object is the total amount of matter in the subject. In mathematics, a transversal is a line that intersects two or more lines at distinct points. Unfortunately, many students and teachers and teacher educators do not have a clear concept of a transversal. Now, examples of generalizations: like poles of magnets repel and unlike poles attract. In a society, there are more consumers than producers. It's not just an observation, mind you. Metals are good conductors of electricity. This again not an observation. It is a conclusion that is drawn from observing a number of metals and their conductivity of electricity. For a fixed mass of gas at constant temperature, the product of pressure and volume is a constant. This is what we call it as a Boyle's law. And then say an example in a generalization in mathematics is two consecutive angles of a parallelogram are supplementary. Most of these may be Greek and Latin to some of you because they are from different areas. And these are the public knowledge, not your knowledge. Because you have not constructed this knowledge, therefore, or let me put it, since I have not constructed these, I don't have the deep or thorough understanding of this. And I may not make meaning out of this. Sense making is an important pedagogical theme that is being followed. Making sense is making the knowledge meaningful to us. And that is, I consider as a necessary condition for to apply that knowledge to different situations or problem solving. Transfer doesn't take, it's not automatic that once you receive some information as processed knowledge, automatically it will not be transferred. Therefore, a deep understanding, a profound understanding, a thorough understanding of the content knowledge is required for a teacher to plan to implement strategies for developing thinking skills, for a student to use these concepts and generalizations for solving of problems, for further processing to discover or construct knowledge, reconstruct rather the knowledge. Yeah. As I said, some people include cognitive, metacognitive knowledge as also a kind of a knowledge, not as a content knowledge, but as a knowledge. But my focus is more on content knowledge. Therefore, I have put three categories of knowledge that one finds in almost every domain of knowledge. And that needs to be used in developing thinking skills. But then metacognitive knowledge is knowledge about the strategy that, first of all, metacognition is knowing about knowing, thinking about knowing in order to improve one's learning capabilities, one's problem solving capabilities. One has to think about how he or she has went about in finding a solution to a problem or in arriving at an explanation or in constructing some knowledge. That is what is called metacognition or knowing about knowing or thinking about thinking. And there are three kinds of metacognitive knowledge, that is the strategies that are used and the tasks or the context in which such strategies are used, and more importantly, metacognitive knowledge that refers to knowing about one's strengths and the weaknesses. That is also called self-regulation, self-appraisal, and one who is good at this metacognitive knowledge can be an independent learner, and he can also be a successful learner in the company of other learners. And some define metacognitive skills and strategies as task analysis, planning, monitoring, checking, reflection, self and group monitoring skills, reading and writing skills, self-regulation skills, and self-assessment. Now, for whether it is based on outcomes or otherwise, for many teachers and students, a curriculum is content. And it is therefore, when one views the curriculum as content, one tries to transmit that knowledge, cover the content. And one of my senior colleague in the Regional Institute of Education, Mysore, used to say, cover the syllabus. Cover the content is syllabus is more or less considered as a synonym to content, and cover the syllabus instead of uncovering the syllabus. So if one has to visualize a thinking curriculum, one has to uncover the content rather than covering the content. When curriculum is considered as content, one tries to transmit the knowledge. And then the higher, more complex kinds of content knowledge, like the conceptual knowledge, which includes concepts and generalization, they are reduced to facts. As I said earlier, definition is included as a factual, say, knowledge, but a definition is a knowledge constructed by the learner. Okay? Can be constructed by the learner, which is a summarization of the properties that one finds in a set of objects or a class of stimuli. But then the proponents of thinking skill consider the purpose is to allow students to become confident in applying what they know to problems and issues in self-managed manner. That is self-learning, individual learning, personalized learning, in both familiar and unfamiliar situations within the acceptable parameters or agreed boundaries. The aim of this approach is, aims of this approach are to enable students to evaluate knowledge. That is, even if it is received, a learner as a receiver information, he can evaluate that knowledge in when a thinking curriculum is implemented. Connect and integrate knowledge. Connecting and integrating knowledge leads to a deep understanding. I have few slides on this integration, how big ideas can be learned, not distinct ideas or concepts as distinct, or concepts and generalizations are a distinct knowledge, or generalizations are distinct knowledge. We can find as a lot of relation in the sense of a superordinate, subordinate, and coordinate concepts, which I will try to explain, because not many teachers, teacher educators, teachers at all levels are familiar with the nature of the content knowledge and how they are formed. That is the reason why even a curriculum is based on outcomes. They are not successful in making students learn up to the expected levels and acquire the kind of knowledge and the skills they are expected at the end of a period of learning experience, end of the learning experiences. Now, since those who consider curriculum as thinking skills and have developed exclusive curriculum to develop programs, if not curriculum, programs for developing the thinking skills. And that's what is called a direct approach, where a curriculum is designed. And curriculum, as you know, is not a compoundum of content, or it is consists of objectives, content, learning activities, and the assessment in an integrated manner. And they are all related to one another, one related to the others. Here, when curriculum is considered as a content, the content is taught. The product of processing information are passed on or transmitted to the learners. In a developmental thinking, two approaches are followed, and there are many programs that are validated in different subjects like physics, chemistry, mathematics, and even in engineering and medicine, programs were designed. And problem-based learning is one type of approach that is followed in medical education. And the infused approach to development of thinking skills is don't separate content from the thinking skills, development of thinking skills, but use content as the context for developing the thinking skills. Since curriculum consists of content, and there are learning outcomes which describe the thinking skills, these can be considered in selecting the content. And then once the objectives, outcomes are decided, and the thinking skills in the outcomes are identified, content can be identified, and learning strategies can be designed for developing the thinking skills. This approach is called the infused approach. And I think every teacher can follow the infused approach to development of the thinking skills. Consciously, deliberately, the thinking skills are to be identified and appropriate strategies are to be designed to develop those thinking skills. Now, since I am for an infused approach to development of thinking skills, because content, I use it as a context. Therefore, I will discuss a few strategies that can be used in teaching of the conceptual knowledge in particular, and and then identify the kind of thinking skills that can be developed in adopting or planning and implementing strategies for teaching of each of these kinds of the conceptual knowledge. Now, but we know, I've said what are concepts. Okay? They are the kind of knowledge, and the concepts refer to a class of objects that have similarities, a class of stimuli that have similarities among the differences. More about the concept and concept learning. But then we know that teachers, as a transmission mode, use rule, example, method. That is, concepts are taught as definitions. That means concepts are defined. Concepts are, the learners are not made to conceptualize the concepts. Therefore, the question that is generally asked is, should we teach definitions or teach to define? When you teach to define, you first make students to conceptualize. Conceptualizing is identifying what are called the defining attributes, the critical attributes, the must-have attributes in a class of the objects. It's all in the air. Therefore, you need to consider some class of objects, okay? And for which since I have made a few slides earlier, I'll use them here. Bear with me if they are mathematical examples. So I'm for one, if there is a change in the pedagogy of teaching concepts, the shift is from teaching definitions to teach to define, and that is the learning approach. We consider the what is a concept we have already discussed, but more with an example. What is concept learning? Understanding a concept, and what evidence indicate the understanding of a concept and how a concept is to be taught. Maybe I'll go to this and then come back to the earlier. Now you see here, this is a class of numbers. A class of numbers or a set of numbers called fractions. I presume that students, if I have to teach what follows as a few concepts, I presume that the students have the concept of a fraction. Now they can recognize numbers as fractions. Okay? They can distinguish fractions from other numbers like integers, and they can also process these examples of fractions. The examples of fractions are the objects under consideration. Now here are examples of fraction. Each number is an example of a fraction. There is no number which is not a fraction here. So there is no non-example. These are the terminology that one should be familiar in order to understand the pedagogy and to plan and use the pedagogy. Every element in this set, I'm using mathematical language. Every element in this set, though it is not represented in the roster form, it has a boundary, okay, and many more can be brought into this class category of numbers. Not any number that is not a fraction. Okay. But then all these have similarities, therefore they have some similarities, therefore they are called fractions. Okay, it is of the form p by q, where p and q are integers and q is not equal to 0. That's what characterize all these the numbers. But what is intriguing is that these fractions, there are a lot of differences, and it's an advantage that there are differences. And these examples are so selected to present the differences that can lead to forming new concepts. That's what sometimes concepts are considered as a category system or categorization. As a process, it is a categorization as a category system. Now, if you have observed, compared, and contrasted, comparison leads to identifying similarities, contrast leads to identifying the differences. So comparing and contrasting I have presented as a derived skill of inductive thinking skill, and these are used in concept formation. Therefore, when you teach concepts to make student to conceptualize or form a concept, construct a concept, they are using the skill of comparing and contrasting. Okay? This is not the only one. You will see that they also use different kinds of reasoning as well. So if you have identified the differences, using each of the kind of difference, what you get is a category of fractions. And again, each category of fractions represent a concept. They represent a concept because in each category, the fractions have similarity. It is that what makes them to be called by. Now, some of you may not be familiar with the concept name subunitary, but then you are familiar with the proper fractions. So what is presented in the first set is examples of proper fractions. They are the examples. They have, all of them have what characterize as a property that characterize a proper fraction, which is also called in some countries as subunitary. Sub means less than 1. And then the second category, they're all similar because each one equal to 1. 1 can be written as a fraction, right? And that's what is attempted here, and that represent equi-unitary fractions. Okay, all positive integers can be represented as a fraction also. Then the third category, they are similar. The three numbers that you have, fractions, are similar, but they are different from the fractions in the first and the second set. And this is what goes on in one's mind when one compares and contrasts. So the comparison contrast of this set of fractions leads to identifying the, using the differences, these categories are formed. In forming, while the difference is used as a criterion for classification, when a proper classification is made, conceptualization takes place, a concept is learned. A concept is learned when the critical attributes, defining attributes, the must-have attributes, all these are present in the critical attributes of proper fraction. What is that? That the numerator is less than the denominator is a critical attribute, is a defining attribute, is a must-have attribute. And all the fractions in the first category have these defining attributes or must-have attributes. Once these critical attributes are identified, concept is formed. They may not know the name, but then they know what are the commonalities that are found in this. And once the critical attributes are identified, when a name is associated, which is only a term or a label or a symbol, then that name or the symbol makes sense. When only names are transmitted or given, they don't make sense. Okay? That the names may be Greek and Latin to the learners. So what is essential is that make the student to conceptualize first and then relate that to a name, which can be made use of in further learning and in defining of the concepts. Though the third category is called the mixed fractions, improper fractions. They are not represented as mixed fractions, but they are improper fractions called superunitary. That means the value is greater than the 1. I think a similar kind of thinking can go on to identify the similarities. Here, the complexity of learning or identifying the critical attributes is more because there are more varieties in the polygons that are presented here than the similarity. So if one has to identify one's attribute, the critical or the defining, which is the four-sided, and there are more varying attributes. They're sometimes called nonsense attributes, irrelevant nonsense attributes, nuisance attributes. Nuisance from the point of learning a concept, because they are to be ignored. The varying attributes are to be ignored, and only the critical attributes are to be identified. And this is the kind of process that goes on in concept learning. And once the critical attributes are identified, here the concept in reference is a quadrilateral. Okay, but you find the quadrilateral, there are different kinds of quadrilaterals. In the sense there are many varying attributes in terms of parallelism, perpendicularity, angle properties. Okay, there's a lot of variation in these figures. But once the critical attribute that these are convex polygons with 4 sides, the concept of quadrilateral is formed. So a concept formation leads to developing the inductive thinking skills, and it can also lead to connecting with other concepts. I may not be able to give a thorough explanation of these moves, but then one's knowledge of the what, when, and how of these moves can help to design a variety of strategies which can meet the individual differences of the aptitude of the students, and some of the strategies can be concept formation strategies. Some of the strategies can be concept assimilated strategy. Though in a concept formation strategy, learner construct the concept, whether he verbalizes or not, whether he defines it or not. A concept is now formed. Gradually, right, students should learn to define also, and in defining, a concept is related to, say, another concept. Now, when I come to the concept maps and then mind maps, where you can see the kind of hierarchy among the concepts, which I refer to as superordinate, subordinate, and coordinate concepts. So some are considered as characterization activity. These are various activities that can be used by the teachers as well as the students. And a sequence of these activities can lead to a strategy. Strategy is some define as temporal. Once you say that one follows the other, temporal is taken care of. So you can have a sequence of the moves leading to a concept formation. You can have a sequence of moves including exemplification and the characterization. That, as you all know, as students, as learners and teachers, that when a strategy is implemented, not every student can conceptualize, and those who do not conceptualize, and when there is the time on task or the instructional time is not kept as a variable, then some learn and some don't. This is what is, some conceptualize, some may not conceptualize. And if you leave it to those who do not conceptualize, will develop more learning difficulties because concepts are related in terms of inclusion and exclusion. Therefore, the concept needs to be explained. And concept assimilation strategy is a strategy that leads to construction of the understanding of the concept by relating with the prerequisite concepts. One can develop an understanding of what is presented. That is, when a definition is presented, concept assimilation strategy can lead to understanding of the definition. When I say understanding of the definition, understanding of the concepts. So the exemplification moves can clarify the concept. You are trying to concretize it, and the characterization moves can help to identify the exemplification moves and say why some object is an example, why some object is not an example. In mathematics, these necessary and sufficient conditions that are used extensively in proofs in algebra, right? Similarly, there is the other kind of knowledge is generalizations. Sujana, please tell me if I'm exceeding the time that is given to me. Please remind me a couple of...
Sir, proceed for another 10 to 15 minutes, sir, please.
Okay. So generalizations, as I said, are inferential statements that relate two or more concepts. Now, if you look at some of the, say, definitions, like again, if I take the mathematics example of two consecutive angles or adjacent angles are in a parallelogram or in a quadrilateral or parallelogram or supplementary, there are a number of concepts that are used, but then the statement doesn't say what are consecutive angles. or what are adjacent angles. The statement doesn't say what is a parallelogram. The statement doesn't say what is complementary, meant by complementary. So therefore, the statement is not a definition. It is a definition that says such a relation exists in a parallelogram. A relation of the angles exists in a parallelogram, and that kind of a generalizations can be used in other learning or proving other generalizations. Basically, in learning of generalizations, two broad thinking skills are used. One is the inductive thinking skills, the other is deductive thinking skills. They're also referred to as inductive reasoning, inductive inference, and deductive inference. It is also necessary to make a distinction between generalization as a product, as an item of knowledge, and generalization as a process. Generalization as a process leads to discovering or constructing generalizations. In most of the subjects, inductive thinking skills can be used, or inductive reasoning can be used to arrive at some generalizations. Some of the strategies that I will refer, not explain, a shortage of time. And in fact, if you had given me 1 semester duration, I would have developed some competence in the use of those strategies, to develop the thinking skills. But in hardly in an hour, it is highly packed presentation. But then I normally don't feel satisfied unless I give examples. Okay, and my students know that I'm not one who is satisfied with the transmission of just the knowledge, but to give a lot of examples as illustrations or exemplifications for clarify, even if I'm using such strategies where the knowledge is presented. Basically, there are two phases in inductive thinking. One is abstraction, the other is generalization. Generalization as a process. In inductive reasoning, one goes beyond what is observed. Observations are the basis for arriving at the generalizations. Once the data or the observations are there, like in concept formation, there are similarities in the observations, which are with reference to generalization. They are called instances, not examples. And the instances of a generalization, there are similarities. And then abstraction is a stage at which the observations are analyzed to identify the similarities. And these are maybe that at this stage the learner try to summarize, consolidate all that is the similarities that are identified. And then the next stage is a extension of the abstraction, and the extension of abstraction is what is called going beyond the observed. Going beyond the observed is when the unobserved, unexamined information, objects are included into the class of the observed, generalization takes place. So here is an illustration of inductive thinking leading to a generalization. Very simple example that I have taken. You might have studied not as a generalization, but you might have done a number of times these what is called as addition facts, but then I don't consider these as conceptual knowledge, but there is a tendency, practice of calling them as addition facts. So here are a few, I call them as mathematical sentences, the closed mathematical sentences, right? And now I've deliberately selected those mathematical sentences which may induce the learner to identify the not critical similarities leading to a generalization, but as critical, non-critical, non-essential commonality, similarity in the observed as an observation. Now, if you analyze, scrutinize, right, you find there are some what I called nonsense or nuisance attributes here, or that are included here, just to make them develop that thinking ability of identifying even the non-critical attributes or nuisance attributes and then ignoring them, leading to a generalization. Now you see here, what is important is these are 3 and 5 are called the addends, and this is 8 is called the addendum or the sum of these two numbers, addends and addendum. The 3 and 5, 7 and 9, 1 and 3. Now there are some similarities in this. I'm not interested in that. But then a learner, the one who is processing this information, might consider them as something important, not which may not lead to a generalization. Like you see here, every first addend is less than the second addend. Okay, and the difference between the two addends is 2, which are not what is required in arriving at a generalization. But what is, you cannot avoid the sum being even numbers. That is what is critical also here. Critical in the sense important, in other words, defining, not in terms of a concept. Now, therefore, to avoid ignoring or to facilitate ignoring that non-critical attributes, I have taken addends as not as numbers with a difference of 2. I have eliminated that commonality here. Okay, and then you see here you also find the first addends are less than the second. Okay, but that also is ignored. Therefore, what is summarized here as the similarities, okay, are cannot be considered as similarities here. Okay, but there is also, you see, all these addends are less than 20. Some might think that whatever relation that is there holds true for addends that are less than 20. There's one possible kind of a response one might get from the students. And therefore, having summarized, if there is such non-critical attribute, then see, you ask them to consider the instances similar to what are presented here, and then see whether the instances they have generated have only what is found here, or they are the extensions of that, leading to a generalization, which is sum of 2 odd numbers is an odd number. This is a property of numbers and the property of odd numbers. So this is only a beginning, and one can this can lead to a number of other generalizations. They form a set of generalizations. One can be considered as a subordinate generalization or sub-generalization of another generalization. This is also an example that generalizations are related in terms of superordinate and subordinate. Though those terms are not used, the meaning is reflected there. Subgeneralization and a supergeneralization. Okay. Another example here is what is looking for a pattern, and then generally geometry can lead to learning of algebra. And this is one instance where a generalization can be represented in a mathematical language, the symbolic language. This kind of an exercise helps to represent what is discovered in a symbolic form, in a mathematical language. And in physics and chemistry, you can find, say, the laws and theories are expressed in mathematical language. We say Boyle's law as P is proportional to 1 by V, which is equivalent to saying that P is inversely proportional to 1. Okay? So that is, if it is written in symbolic form, it represents the Boyle's law. Okay? Broadly, the constructive strategies, you can also call them as process-oriented strategies. Okay? Those include inquiry-based, problem-based, project-based. They are all, for your information, are inductive thinking strategies. Okay? There is a similarity in the steps that are followed. Maybe they vary in the sometimes in a sequence, or the role of the teacher or the role of the student, the kind of data that can be used. And the other is called the instructive, which is directive. But what is, I'll try to summarize. What is also important to note about this instructivist direct strategies is that each one of these can lead to understanding, meaningful learning of a knowledge that is presented. And these strategies, what Ausubel calls it as a interactive model. There are a lot of thinking, discussion that can go on in this kind of a strategy. It is not direct, doesn't mean it is lecture method. Expository doesn't mean it is lecture method. But what is similar in all these instructivist strategies is that knowledge to be learned as a defined, processed knowledge. The product is now presented early in the sequence. Whereas in each of these constructivist pedagogy, the learner is the constructor of knowledge, is considered as active in constructing knowledge. Because of the involvement in learning, the learner is motivated. The kind of problems that are presented in each one of these kinds of strategies as a first step will generally motivate the learners to learn, and other steps require the learner to use various thinking skills leading to generalizations. So all these strategies can lead to discovery of the generalization. But then in the instructivist strategy, though the generalization can be presented early in the, or is presented early in the sequence, some of the moves that can help them to understand, and through questioning and with the prerequisite knowledge of the learner can construct the understanding or the meaning of the generalization that is presented. That is what is also called sense making. We generally say, do you make sense of it? Is it meaningful, or is it something a nonsense? What is not understood is, I consider, is a nonsense. So, say in the process-based strategies, the You can see as the titles, there are process skills that are there. Here, presenting a problem, sensing a problem, becoming aware of a problem, noticing then some is not getting that word, discriminant, not discriminant, unusual phenomena, that is hypothesizing, testing of hypothesis, generalizing. These are all process skills, and almost all process strategies have these steps, and each step require use of the process skills, and teaching through generalization, number of inductive and deductive skills can be developed. Now, one thing that I would like to point out here is that induction doesn't lead, or inductive thinking doesn't lead always to true conclusions, because of the number of cases, you call it as instances that are considered is non-representative, inadequate, then it can lead to, as you can see, as you might have seen in those example that I've presented for arriving at a generalization, that sum of 2 odd numbers is a even number. Sometimes students can overgeneralize, undergeneralize, not arriving at a generalization which is already there in the public domain, and the learner is only reconstructing that knowledge. Okay, so the direct or expository, as per Asbel, the interactive model follows is based on a saying, and I would like say it is rhyming, and then you can like it. Tell them what you want to, what you are going to tell them, or what you want to tell them. Tell it to them. Tell them what you have told them. Okay. So the first stage is called the introduction stage, where the learner is made ready to learn. This is also a stage where learners are motivated to learn what they are going to be presented. And then the second stage, tell it to them, is making a statement of that knowledge. And the third stage is the explanation. And we all know, as teachers, you should know that there are 3 kinds of explanations, namely the interpretative explanation, the descriptive explanation, and the reason-giving explanation. These are called the what explanation, how explanation, and why explanations. And these are all related to the thinking skills. Okay, and through the students interpreting the knowledge, through students describing the knowledge or narration. In social science and languages, you can use description as a narration, and then give reasons. Now we have said justifying statements, conclusions, okay, justifying assertions is nothing but justifying the truth of, or establishing the truth of that knowledge, and also justifying the process that is used, and also assessing the quality of the process that is used can be explained through the reason giving by the students or by the teachers. This is only a summary. And then I was referring to the big ideas, making meaning, developing structures. Mind you, whether we know it or not, all subjects has the structural knowledge related to the kind of relation among the different kinds of knowledge. Here is one example of a hierarchical relation among the types of correlators. You have seen in one slide the different types. Now they are classified here. I think I can take 10-15 minutes to explain, but then there's short of time. Okay, this is if a student can prepare this kind of a concept mapping, which gives not consider each type of a quadrilateral as a distinct concept, but as a interrelated concepts in terms of superordinate, subordinate. I just mentioned for one, like you see here, quadrilateral is a superordinate concept for a kite. Quadrilateral is a superordinate concept for a parallelogram. For a square, parallelogram is a superordinate concept. For a square, rectangle is a superordinate concept. Rectangle is a first order subordinate concept of a parallelogram. Square is a second order subordinate concept of a parallelogram. Rhombus and rectangles are coordinate concepts. I said maybe half an hour, 1 hour, I would have made this idea meaningful to you. Now, I also for helping biology teachers in Andhra prepared content analysis as a part of content analysis, prepared a conceptual hierarchy among the types of leaves, particularly the compound leaves, which are classified as pinnate and the palmate, and pinnate are again classified as unipinnate, bipinnate, tripinnate, pinnate. You can find them many in your, I don't know, college garden or in your surroundings. And the unipinnate is also called peripinnate, imparipinnate. Palmate as unipolate, bipolate, tripolate, multipolate. Okay, and the Andhra, the maths teachers are now, a group of teachers are engaged in textbook preparation. There are a lot of confusion about content analysis and the relation among the concept. To help them understand, and they were also, I think, asked to prepare mind maps, and to help them see, I've taken not 1 hour, 2 hours, couple of days, and to prepare this kind of a mind map which express the relation among the concepts. I think I have taken more than the time that is allotted. Thank you, Sujana, and the organizers. I think I would like to listen to the chairman of the session, who is also a mathematics teacher. Back to organizers.
Sir,
Shrikant.
sir, shall we open this? Can
Yeah.
we conclude, sir? Now it's almost 11:45. Next resource person, I think so. He will be ready, sir.
Another also is waiting. My student.
No, because we had to give some time for discussion also. Most of the participants have some doubts too. Anyway,
Okay.
I shall share your mail ID, sir. But some of our participants want to interact with you directly, sir, please.
They can do it later also. Like
Okay.
that textbook writers used to do, contact me.
Okay, sir.
Yeah, if there are some doubts, let it be known. It gives an idea of the
Okay, sir. Okay.
effectiveness of my presentation.
Okay, sir. Okay. Sir, would you like to conclude or want to say some more time, sir, or we shall open it for discussion?
No, my presentation is over.
Okay, sir. Okay, sir.
I can go on for
Thank you very much.
more hours, Sujana.
Yes, sir. Yes, sir. Yes, I understand, sir. Thank you very much, sir. And we are very happy to announce that here. Initially, we should have announced it. Our resource person, Dr. K. Doraswamy Garu, is a proud alumni of our institution, PVKN Government College.
First batch in that building.
First batch. And a really proud alumni, sir. And he is also, and another thing I wanted to say, the resource person is also one of my best teachers 26 years back in RIE. Thank you very much, sir. And I request all the online and offline participants to ask queries. Now it is open to online participants first.
Hello, sir.
Yeah.
Let me know about teacher education programs.
Eh?
Sir, myself B. Ramesh Chandra Babu,
Yes.
Faculty of Mathematics. So my query is evaluation of innovative teacher education programs. I want to know about that one, sir.
How to evaluate innovative programs, or some reports of the evaluations done?
So, we want to know about that program, sir.
Yeah, I'll prepare a list and mail it to Sujana. She can share with. I don't have right now with me. I can prepare a list of programs that were OBE based and which were evaluated also, not only in mathematics, other subjects, not only at the school level, but higher education level also. I can share with you some articles or reports of the evaluations.
Thank you, sir. My name is Dr. Mohan Behra, PVK College, Department of Botany. First, I would like to thank for your energy level, sir, because it's a real extempo. More than 1 hour you have taken, sir. It's really wonderful. I have a lot of doubts, sir. Later part, I will communicate to you through email. But at present, I would like to know, sir, are you hearing me, sir? Hello.
Yes, yes. Yeah,
Yes.
yeah.
Sir, how do I incorporate critical thinking into my course? Number one question. Being a faculty, how do I incorporate critical thinking in my course? Number two,
Okay.
how do I assess the critical thinking level in my students? These are the two core questions, sir.
Now, first of all, you have to identify what thinking skills are to be developed in a botanist. Okay, student of botany or a botanist. And then you have to select the content and identify the thinking skills, design a strategy incorporating these two, and then implement. Okay. I don't know whether I made the point clear. You have to identify the thinking skills, not all of them. Now, I have defined what is thinking skills. Thinking skill is considered the highest level of higher order thinking skills by some. Now, if you identify the subskills, it has the inductive thinking skills and the deductive thinking skills. And science is a subject is amenable for developing the inductive thinking skills. Okay, science is a subject where the hypothesizing can happen with the appropriate data. The hypothesis can be tested, conclusions can be arrived at. So that means you are developing the skills which are part of the thinking.
Okay, sir. Thank you. Sir, one more query, sir. Under
Yes.
conceptual knowledge, you mentioned in earlier slide that conceptual knowledge, you are given two examples, sir. Tree plantation and parasites on organisms. How can you interpret these two?
No, these
Once
are,
again, sir.
see, transplantation is a process. It's called a process concept in science. There are many process concepts in science, particularly in biology. Respiration is a process concept. Digestion is a process concept. Osmosis is a process concept. Endosmosis is a process concept. Exosmosis is a process concept. Now you see that they have to observe the process. You have to give instances where osmosis is taking place, not knowing the term osmosis, but the flow of water from a solute, right, through the what is called root cap into the cells. To Jaila. Okay. That's one example. See, they have to see plantation is going on. Not every plant can be transplanted, isn't it? So that is kind of a non-example for transplantation. Like paddy, you can do transplantation. Okay.
Okay, sir. Thank you. The last one, sir. Last one, under expository strategies, you mentioned, sir, introduction, focus, objective, and motivation. So my question is, how the focus the term, how will incorporate after the introduction, in between introduction and objectives?
Now, if you
And,
read the, okay, complete your question.
Yes, sir, that is only. After that, finally, motivation.
Yeah,
How the
there is,
sequence will be, sir?
yeah. I used to tell my student teachers and teachers who used to come for professional development programs that I would rate teachers teaching if he or she can introduce a lesson through problem situation. A problem situation makes the student to realize the inadequacy of the knowledge and the skills that he or she possesses. But a problem is a problem. And if a student accepts the problem, that means the question that poses a challenge to him, then he is motivated, right, to find a solution to it. Therefore, you can use a problem situation like, why plants built? You are a botanist. Why plants built? You can provide, pictures or videos, or you can make student observe going across, the school garden or a college garden. And if you have intentionally put some parts where the plant is wilted, now it is a situation that may lead to a student accepting to give a reason why plants wilt. Plants wilt because of exosmosis. I've learned botany, biology up to 12th class. And that was one of my favorite subjects, though I landed
Yes,
in
yes.
mathematics.
Basically, we are the plants.
I can
Basically, our subject is botany.
Yeah,
We're basically from that subject, sir.
Good.
So most of your lecture, you are given the botany examples.
I'll send you a concept analysis that I have done for master biology teachers of Andhra Pradesh. Right
Okay.
now,
Thank you.
right,
Thank you so much,
now,
sir. Thank you.
see what goes on in concept learning, planning for concept learning.
Thank you, sir.
Welcome.
I request other participants to ask you questions through email, please. As we are running short of time, we would like to conclude this session. I request now reporter Dr. T. Raghuraman to say a vote of thanks to this session, please.
I feel it is an opportunity to act as a reporter for this session. Dr. K. Doraswamy Naidu, sir, have given wonderful lecture on the topic strategies for development of higher order thinking skills in outcome-based education. Sir, in his lecture, gave detailedly about the theory of information. According to theory of information, it can be divided into two categories, like construction of knowledge, and the second one is thinking skills. Sir has explained very well about these two items, and also coming to the thinking skills and teaching thinking skills. The thinking skills can be categorized into three types: inductive thinking, deductive thinking. Third one is critical thinking. So in that we have to concentrate more on critical thinking. So critical thinking is it is also derived skill. It is also a derived skill from inductive and thinking skills. And here, according to Bloom's taxonomy, analyzing, evaluating, and creating, these are three important items. And Sir in his speech explained clearly about the kinds of knowledge. There are three kinds of knowledge: factual knowledge, conceptual knowledge, third and procedural knowledge. So sir explained these three items with a lot of examples. And there is fourth one is also there, metacognitive knowledge. These are also explained in this lecture. And coming to sir explained another topic also, curriculum content versus thinking curriculum. So this is also covered in the SARS lecture. Now, different approaches to develop thinking skills were also explained in the lecture. That is a direct approach and infused approach. These were also covered in the speech. How to comparing and contrasting skills were also improved for betterment of understanding, and similarities, comparing skills were also understand, and different types of strategies, inductive thinking skills were also explained, and phases in inductive thinking, that is abstraction and generalization, were also explained by the sir. And finally, sir has gave big idea like concept mapping and mind mapping. Thank you, sir, for giving a wonderful lecture. Thank you very much, sir.
Thank you.
Thank you very much, sir. Shall we conclude this session, sir, or would you like to speak something to the audience?
Thank you. Thank you. Next time.
Thank you very much, sir. Thank you, sir. I will share your PPT and your mail ID to the participants, sir.
Okay.
Once
Okay.
you share with us.
Right.
Okay, sir. That will be really helpful for them to build their concepts in their subject disciplines, respective disciplines. Okay, sir.
Okay.
Thank you very much, sir.
Welcome. Thank you for giving me an
Thank you,
opportunity
sir. Thank you, sir.
to be. Okay. Thank you.
Thank you, sir. So, sir, I think we'll take 5 minutes break and join for the next session. I request next resource person, Viswanatha sir, to kindly bear with us. I know you are there from right 10 o'clock. Sorry to say this. We'll just start the next session after 5 minutes, please, sir.
His
Thank you, sir.
teacher was responsible.
Yes, sir. Actually, he is your student, no, sir?
Yes.
He has done PhD under your guidance. Yes, we do remember, sir, when we are